Okay, so now we're going to look through this in the context of one particular kind of system, which is x86. And you may remember some of this from 261, where you did this for x64, which is similar to x86. So on x86, there is a stack pointer register, which always points to the top of the stack. So again, we draw our stack diagrams upside down in computer science a lot. So these are higher addresses, these are lower addresses, and the stack grows from the higher addresses down to the lower addresses. So the stack pointer would be pointing somewhere down here on the diagram. There is also a base pointer, which points to the beginning of the current frame after saving the old base pointer. And so currently the base pointer would be pointing here. So here we have function foo, bar, and baz, and this is a snapshot of the stack inside of baz. So we've called foo, that's the yellow stack frame, foo called bar, that's the orange stack frame, and then bar called baz, which is the blue stack frame. So the base pointer here is what we called it in 261. Here in 430, the authors of our textbook call it an environment pointer or a dynamic link. Those are all essentially synonymous terms, and I'm going to use them interchangeably. So the calling conventions here are that the callee may use the AX, CX, and DX registers, or the EAX, ECX, and EDX registers, which you may remember those names from 261. The callee has to preserve all the other registers. Parameters are pushed in reverse order. So you'll notice here that bar, when it calls baz, and that's a typo, that should be Z. When bar calls baz, it passes X and C, but then on the stack, you can see that C was pushed first, and then, down here. So you can see that C was pushed on first as Y, and then X was pushed on as X. And then the return value is saved on AX, so we don't need an explicit place in the stack frame for the return value. So the other things that are in the the other things that are in the activation record or the stack frame here are the return address, denoted here as return IP. So this is where we will go back to in bar once baz is finished. And then base pointer. So these are the dynamic links that your textbook talks about. So this is where we would transfer control back to. This is in the program code, right? This address is somewhere in the code of the program. This is the base pointer for the previous function, which means that it's going to be pointing back to here, which is the slot in the stack where we store the base pointer for foo. And you can see that these base pointers form a chain through the stack. This is what enables us to walk up the chain. So when you, for instance, run a program in GDB and you get a segfault and you want to see where on the calling stack you are when you got the segfault, this is how GDB walks up the stack to see what's going on. It follows these dynamic pointers. Okay, and then the other thing that's stored here that you can see are the local variables. And one thing that you'll notice here is that when you're inside of a function, so for instance, let's think about baz here. So baz has two parameters, and it also has a local variable. And so we have the base pointer here, and you'll notice that we can always access the parameters to baz using a positive offset from the base pointer. So that's moving up the diagram here. And then we can access its local variables using a subtraction, a negative offset from the base pointer. So I just want to show you a little bit of the assembly code for this. This is not relevant necessarily for 430, but it might help connect the dots between 430 and what you did in 261. So this is some code for the prologue in x86, and it consists of saving the old base pointer, saving the top of the stack as the new base pointer, and then reserving some amount of space for the local variables. Once you're inside of a function, again, like I just said, you can access the parameters to that function using a positive offset from the base pointer. You can access the local variables using a negative offset from the base pointer. And then the epilogue consists of instructions that restore all of the things that the prologue set up. So it takes the stack point, it restores the old base pointer and stack pointer, and then it pops the return address and transfers control to that return address. And so when you do the call, so the pre-call and the post return would look like this. And I haven't given specific instructions here because each of these things would expand to multiple instructions. But you would need to push all the parameters onto the stack using push instructions. You need to push the return address and jump to the function, which in x86 is done using a single instruction, the call instruction. And then when you're done, you'll need to pop those parameters off to the stack. So hopefully this helps connect what we're talking about this week in 430 with things that you may remember from 261.